Okay, so if we're going to find the max and min, I know that in 3U or 3M, whichever course you took, you probably completed the square. Okay, that was probably the normal way that you did that. Um, so remember that you could have quadratic in vertex form. Oops, that's okay. We could have a quadratic in vertex form, and HK would be the vertex, right, which is also the maximum or the minimum. So if we have a concave up, we would have a minimum point, and if we had concave down, then we would have a maximum point, right? So generally, we completed the square, and we were able to find the values of h and k. If you think of the quadratic formula, so the quadratic formula allows you to find the roots. So let's say we had a graph or a quadratic that looks like that. So the quadratic formula allows us to find the roots of the quadratic or the parabola. So think about the formula. The vertex is in the middle, right, which is on the axis of symmetry. So it's on the very middle of the graph, and the graph is symmetrical. Okay, so the plus minus in the equation is saying if I start at the middle and go to the right or to the left, I'll find these 2 points. So the square root, this part of the quadratic formula, is telling you what the middle is. It's telling you the value of x in the middle of the vertex. And then we add this part, this discriminant, right? This discriminant defines where the roots are. So sometimes, if you remember from grade 11, we might just use the discriminant to determine how many roots there are. So you would have said, okay, b squared minus 4ac is the discriminant. And that will tell me how many roots there are, whatever that number is. If it was positive, I had 2 roots. If it was negative, I had no roots. And if it was 0, I had 1 root. The b minus 2a part of the quadratic formula tells me where the middle is. Right? So we find, so in this quadratic formula, we find the middle, and then we add a number to get the right side root, and then we subtract a number to get the left side root. So instead of completing the square, I could just use this part of the quadratic formula to find where the middle is, because completing the square is a little bit tedious to do. So for example, if I wanted to find the max of this function, I want to know where does that maximum occur on the x-axis, and I'll just use negative b over 2a. So if you think of standard form, ax squared plus bx plus c is standard form. Okay, so in this equation, the coefficient on x squared is a, the coefficient on x is b, and the number without a variable or a letter is c, the constant. So in this quadratic, the b is 8, and then a is negative 2. So I'm going to simplify that, and I get 8 divided by negative 4 is 2. Sorry, negative 8 divided by negative 4. So I know the middle occurs at 2. Okay, therefore the maximum occurs at x equals 2. And then if I want to find y, I just sub that back in. So I write out the original equation. And then we're going to substitute in the value we found for x to be the middle. So we'll put the 2 into the equation. What's that for? Negative 8 plus 16 minus 3 and that's 8 minus 3 is 5. Okay, so the maximum of this quadratic occurs when x is 2 and y is 5. Okay, if I were writing it in vertex form, I just found the h and k. So I know that the stretch is -2. That's the coefficient on the x squared. And then I know it would be x minus 2 squared plus 5 because I just found h and k. That's the vertex. Okay, so it's just an easier way to put it in vertex form and to find the vertex. Okay, so let's have a look at this one. State whether the function has a max or a min. Find the coordinates. Well, I know it has a max and min based on the leading coefficient. Right? If the leading coefficient is positive, I know it has a minimum. So let's say leading coefficient is positive. It's going to open up. So that means it's going to have a minimum. If the leading coefficient is negative, it's going to open down, and therefore it would have a maximum. So this one has a leading coefficient of +1, so it is going to have a minimum. Okay, and then we want to find that. So we'll use our formula x equals -b over 2a. And in this case, b is -2. So don't forget to put that in brackets. So you have minus that's in the formula, the negative, and you have a -2. And then a is 1. So that's +2 divided by 2 is 1. So my vertex or minimum occurs at x equals 1, and then I'll just put that back into the equation of the quadratic, which was -2x minus 20. So -21. So the minimum occurs at 1, and the y value is -21. And if I were to put it in vertex form, it would be y equals 1, x minus 1 squared minus 21. Okay, so it's a lot faster to do that way than completing the square. Completing the square can be, especially if there's a leading coefficient, completing the square can be a little tricky. Okay, let's see what we have next. So roots. So the roots are the x-intercepts of the graph, or sometimes we call them the zeros, or sometimes we say solve, right? You might see the word solve or find the solution. Everything is the same thing. Find the value of y, find the value of x when y is 0, okay? So in order to find the roots, you can do two things. You can try and factor, or if you can't factor, you can use the quadratic formula. Okay, so here's two questions given. So A, these are quadratics. So the first thing I'm doing in order to find the roots is I will replace f of x with 0 because that's the definition, right? Find the value of x when y is 0. So we'll put a 0 in there. And then we might see if we can factor. I think I can factor this because it's a simple trinomial. So I know 5 times 3 is 15, and I could put a negative on the 5, a positive on the 3. And then once I've done that, I take each factor, set it equal to 0, and solve for x. So those are my two x-intercepts. So if you can factor, it's quicker and it's pretty straightforward. The quadratic formula will always work. You're going to get the same answer. So let's do it using the quadratic formula. And if you are writing a test or evaluation, the quadratic formula is available usually with the question. Okay, negative b. So in this case, So it's negative, and then b is also negative. So don't forget to put that in brackets. Make sure you don't make a sign error. B is negative 2. Make sure it's in brackets so that when you square it, you get a positive. A is 1, and C is negative 15. And that's all over 2 times 1, 2a. So we get 2. And then in the square root, we get negative 2 squared is positive 4. Don't forget you have a negative times a negative, so that's a positive 60 over 2. So then we get 2 plus or minus root 64. So we have two roots. We have 2 plus root 64, which is 8. So that gives me 10 divided by 2 is 5. And then we have 2 minus root 64, so minus 8 divided by 2 is negative 6 divided by 2 is negative 3. Okay, so you'll see that whether you factor 5, negative 3, or whether you use the quadratic formula, you're going to get the same result. Okay. B is 2x squared plus 9x minus 5. And we'll put it equal to 0. Just make sure I get the signs right. Plus 9x minus 5. Put that backwards. 2x squared plus 9x minus 5. Okay, I think I can factor this. It's a complex trinomial. So 2x squared has got to be 2 times 1. 5 is 5 times 1. So if I do 5 times 2 is 10. And 1 is 9. So plus 10 minus 1. So you need to factor whatever method is makes sense to you. Okay, if you want to do decomposition, if you want to do crossover, whatever method works for you, you're going to factor it and then you're going to solve for x. And you can also use the quadratic formula. If you don't know how to factor it, you can always use the quadratic formula and get the same result. Okay, let's see if there's any questions here. Okay. So once you have reviewed the process of finding the roots and also finding the vertex or the maximum minimum, then you're going to get some word problems and some applications. Okay. So this question says find two consecutive numbers such that their product is 72. Okay, so what are two consecutive numbers? Well, consecutive means one right after the other. Right, so 10, 11 are consecutive numbers. 5, 6 are consecutive numbers. So if I called the first one M, the second one would be one more, right? So those are representing two consecutive numbers. I don't know what they are right now, but I know that the second one will be one more than the first one. I also know that their product has to be 72. So product means multiplication. So that means the first number times the second number has to equal 72. And now I need to solve for M. So I'm going to expand. I'm going to expand my brackets. And I want to solve it, so it has to equal 0. So I'm going to bring the 74 to the left so that everything's on the same side. And then I want to see if I can either factor or you could use the quadratic formula, whichever method is convenient for you. So we'll say factor or quadratic formula. And so I'm pretty sure I can factor this. Two numbers that multiply to get 72 are 9 times 8, and it has to be positive 1. So positive 9, negative 8. So this is what I end up with, negative 9 and 8. So what does that tell me? Well, if m is negative 9, then m plus 1 is negative 8. If m is 8, then m plus 1 is 9. So then I want to check. The other requisition or requirement is that when I multiply together, the product has to equal 72. So negative 9 times negative 8 are consecutive numbers, and they multiply to positive 72. And 8 and 9 are also consecutive numbers, and they also multiply to get positive 72. So I have two solutions. It could be 8 and 9, and it could also be negative 8 and negative 9. Okay, so sometimes you'll get two answers, and sometimes only one answer makes sense. So let's say, for example, you're trying to find, let's say these were lengths, right? Maybe it's the length of a rectangle. Well, negative 9 and negative 8 wouldn't make sense in that situation because you can't have a negative length. So you have to look at the situation, the application, and see if the answer makes sense, because sometimes you'll get two solutions and only one of them will make sense. Okay, this is a typical quadratic question where you have a path of some sort of projectile, or in this case it's a person diving off a cliff. Oh, it's a diving board actually. So he's on the diving board and he's jumping off, right? He's going to hit the water. So you've got a parabolic shape, and you have the equation given. So it says, how long does it take for the diver to hit the water? So I have to ask myself, am I trying to find the top or the vertex of the parabola, or am I trying to find the bottom or the x-intercepts? So I want to hit the water, so that means I'm trying to find the bottom, right? And it is a parabola, so you're going to get two answers. But in this case, only one is going to make sense, because the answer on the right is where it hits the water. The answer on the left is probably going to be a negative value. And since I'm looking for time, I can't have negative time. Okay, so we have to find, in this A part, we have to find the x-intercepts, because I want to find the bottom of the graph. So I'm going to use the quadratic formula, because I can't factor this. Okay, so what is B? B is 2. A is negative 4.9, and C is 3. You'll see the coefficient of negative 4.9 quite a bit if you're talking about projectiles, because that's the measure of gravity. So generally you'll see that in the formula. Okay, so we have to figure this out. We need a calculator for this. So it's going to be plus or minus. So let's just grab a calculator and plug this in. So I'm just going to do it all together. 4 times 4.9 times 3. So keep in mind you have two negatives here, so that's a positive. Plus 4 is 62.8. Okay, if an error is made, it's generally missing a sign. So one answer will be negative 2 plus the square root of 62.8 divided by negative 9.8. So we'll calculate that. And we get negative 0.60. And then we're going to have -2 minus the square root of 62.8 divided by -9.8. And we get 1.01. So then I have to ask, and this is in seconds, I have to ask myself which answer makes sense. Well, I know that my answer has to be a positive value because time, right? This is 1.01. This one is the negative value. So that negative value does not make sense, right? I'm looking for time. So the answer is 1.01 seconds. This one does not make sense. Or it's not possible. Okay, so that's finding where it hits the ground. B says, what is the maximum height the diver achieves? Well, now, what part am I looking for? I'm looking for the top, right? So I'm looking for the vertex or the maximum. And so I can use my formula for the maximum is -b over 2a. Okay, so b is 2 and a is -4.9. Correct? Yep. Okay, so let's calculate that.
Please excuse this interruption. Would Anna Marie please report to the main office? Anna Marie to the main office, please.
So the maximum height occurs at 0.2 seconds, and the question says, what is the height? So the height would be the y value that goes with this x, right? This is the time that it occurs, so now I have to find the height. So we're going to put that time into the equation. What's the last number? 3? Yep, plus 3. Okay, so we'll just figure this out. And we get 3.2, let's say meters. I think it's in meters. Does it say units? No. Yes, it does. It's a 3-meter diving board. So that makes sense because it's a little higher than the diving board, right? So you think about him jumping up from the dive. So he starts from a 3-meter diving board, and then this is 3.2 meters, right? So he's going up and then down. So that makes sense. And then see what is the domain and range of the function. Well, the domain and range for this specific function, we have to think about this logically, because normally we could use any number for the domain. So we're going to say x is all numbers, but we are restricted because x represents time, right? On the domain or the x-axis, we're representing time. Well, we can't have negative time, right? So it has to be bigger than 0. Can't be negative. And then it's going to end where he hits the ground. So it's going to be from 0 to 1.01 seconds, right? And then he's hit the water. So all those numbers in between. So time starts at 0, and then he hits the water at 1.01 seconds. The range, I'm going to use any number, but the highest point is 3.2, right? That's the highest he's going to go. And then the lowest would be 0, because once he hits the water, then that has a value of 0. So the range has to be between 0 and 3.2. So once you know the max, and once you know the time he hits the ground, then you'll be able to state the domain. and the range, okay? But you need that information to determine that. Okay, sec.